Previous section, we described the data type, module properties, and module methods associated with LabVIEW IO. By the end of this module, you will be able to handle FPGA IO errors. Okay, let's talk about handling FPGA IO errors. So by default, you might have noticed that the IO nodes do not have any error terminals. However, if you do want to look at the errors for a particular IO node, what you can do is you can right-click that IO node and select Show Error Terminals. And once you've done that, it'll look like the screenshot that you see to your right. So in that screenshot, notice that the error terminals do appear, and you can extract that error information and send it to error handling code. So error information is useful for debugging and validating data, and it's essential in some cases, for example, if you're working with some safety equipment and things like that, but it uses space on the FPGA and can slow execution. So every time you're outputting the errors, it takes some FPGA resources to actually implement that. So in general, you only want to show the error terminals if you really need to use something with those errors. If you're not using that error information, you just typically want to not show those error terminals. Okay, so now let's talk about error cluster optimization. So just some things to keep in mind when you're dealing with errors on FPGA. So when FPGA resources are limited, these are some things you can do instead. So if you're only showing that error terminal and the only reason you're using the error wire is for sequencing and for determining the order of execution, then you shouldn't be using error terminals for that. Instead, you should use a sequence structure for data flow instead. If you're using a sequence structure for data flow, you're not going to have to use extra FPGA resources to communicate that error information along that error wire. So don't use error wires only for sequencing. Instead, you can use a sequence structure for that. Again, only show error terminals for modules whose functions are critical to that system operations. So, for example, only show that error terminal if you're actually going to need to use that information about the error in your program. Also, if you have a IO module in multiple places and you only want to check on some of the general errors that are associated with that particular IO module, then show the terminals only once for that module, and then you can kind of periodically check the errors on that module instead of showing the error terminals on every instance of that particular IO module. And that's one way to save space and not have to use so much space for every single time you're showing that error wire. Sometimes when you're programming LabVIEW for Windows, you use the error clusters and you kind of pass them through your entire program and then show the error at the end. In FPGA, you don't want to do that. It's going to take up extra resources on the FPGA that you don't necessarily need to use. So instead of passing the error cluster all the way through your program, one way you can save space is you can handle the error right where it occurs. So for example, if you have an IO node where you're monitoring the errors for it, you can unbundle the error wire right there and then take a look at those items and handle that error immediately instead of having to pass that error all the way through your program. That way you fix the error immediately and you don't have to use extra resources passing that error all across your program. So this slide talks about error clusters for reliability. So some examples of FPGA IO errors that need to be handled are things that are associated with safety critical operations. So for example, if you've got some IO and it's controlling a large motor or something like that, that might endanger people's lives, then you might want to check that IO and make sure that that IO is working properly. Other ones are there's module specific error codes for specific LabVIEW modules. So sometimes you'll need to use that error for a particular instance. So for example, if you're using the NI9802, which is a removable storage module, there's a particular error code that's associated with file not found. So if you need to check that for that particular error, you'll need to use the error wire for that. Also, if you're using CAN modules, there are specific error codes that are associated with timeouts. So you might need to use the error wire for that as well. Another thing that you can use errors for is if a module has been removed from your CRIO, it's also going to output an error associated with that. So you can use the error to check whether your module is actually in its slot and operating correctly. Now you can handle FPGA IO errors. Next, we will implement loop execution rate using the timing express VIs.